And we are live.
Right.
Live from Atlanta, live from San Jose. It's Ed Bailey and Nick Hudecker here. We are here to talk SREcon recap. We're going to talk a little bit more about LogStream deployment scenarios using persistent queuing. How you doing, Nick? How's it going?
I'm doing really well, man. How are you?
Good, good. Weather's cleared up. It is gorgeous.
Yeah, it's always nice here, so I really got nothing to say, but I'm really happy. It's Thursday. It's St. Patrick's Day, so I got my green on. Going to get my whiskey on later, and yeah. So I had a chance to drop into SREcon, as you mentioned, up in San Francisco earlier this week. Really fun event, great content, and I'm excited to talk about persistent queuing in LogStream. So it should be a really fun conversation, and we'll post this up later if there's any comments or questions. All right. Okay, so where do we want to kick off?
So tell us, you were at SREcon. Tell us what were they talking about? What's the big focus for SREs this year?
SREs have always kind of been this like weird amalgamation of roles. I think everybody. I think it's common knowledge they started at Google as kind of this developer services kind of role. I think is one way to think about it. But there's still kind of a mismatch of not mismatch. I don't have the right word. This amalgamation of a lot of different things, like in groups they work with. I finally learned what SRE stands for, which I guess is my key takeaway from SREcon, and that's simply reboot everything, which is how I used to deal with things when I was a sysadmin way back when. But there was a lot of conversations around open telemetry, a lot of presentations. I learned quite a bit about it. There were a lot of presentations around incident response as far as like outages. There was a really interesting presentation from a woman, Courtney Nash, about why mean time to recovery is a bad metric to use. You should be looking at more like median time to recovery, which I thought was, intrinsically, you kind of know that like, okay, that's a really interesting way of thinking about it, but I've never kind of reconsidered, what MTTR, really represented and how it could be a flawed measurement. But her presentation should be available, I think, later this week online, and you can find her at Courtney Nash on Twitter if you want to follow her. So that was a really interesting kind of, forcing your brain in a new spot presentation. And then there was another one. Go ahead.
That's what I mentioned. So I've been following Courtney for some time, and the math behind MTTR is incredibly misleading. And this is something when you get into I used to work with the incident management folks and measuring these things, and you find out why it was median, because more oftentimes than not, you wanted to make it look a little bit better than it actually was. And in terms of how you're representing it, it was always amazing how you take the numbers and how you represent them. Is a big difference, but as Courtney has pointed out, and quite correctly, it's misleading. Was there any discussions around terms like SLO and Air Budget? Those are typically terms that SREs really are into.
There were a lot of conversations around SLOs. I didn't hear Air Budget though, and so I think I think there's some people are really into SLOs. Others are, well, maybe this is not the best measure to use.
Yep.
Service level objectives. I've seen a lot of competing terms getting tossed around, so many that I can't remember them, frankly, around like, well, what other ways should we use to validate that we're delivering what we say we're going to be delivering? And I think it's still an early spot. I think there's an assumption. I think, I live in Silicon Valley, obviously, and I think there's this assumption that, well, once a Google or a Facebook or a Netflix starts to talk about a new practice, it's like game, set, match for everything that came before. It's still really early for SREs, right? And it's, you could even argue that it's early for software engineering, right? Even though we've been doing it for so long, it's always evolving, right? And deployment architectures are always evolving. Hey, Michael, thanks for joining us. And so, SLOs are the first iteration of how we'll measure things or how they'll measure things. But I don't think it's going to be the final answer. I think it's going to keep evolving.
I completely agree. I mean, just give you some parallels. People have been building bridges for how many hundreds, if not thousands of years? And so in terms of maturity and the architecture and the engineering behind bridge building is a fairly mature process. Software engineering, let's call it 50 years. And so, I think there's a long way to go. There's just an enormous amount of evolution in front of us. Software, SREs, everything about IT.
Yeah, we're still, like in the space we're in, right? Observability. We see dozens of companies in the space, and it feels like we're in the third inning. We're still at warm-ups, right? We're still at batting
Yeah.
practice right now for observability. And
My
so,
most common question I get is, what is observability?
and you're not alone.
Yeah.
I do a lot of educational work on that, kind of one-on-one level, where is this thing? What is it? How does it fit? But we're still very early. And I think, that really came through in the SRE conversations as well. One thing that was really interesting, and maybe I'm projecting a little bit, but SRE is a really diverse role, and the people at SREcon were a really diverse group of people. And so it was great to see. There were a lot of women presenting. There was a lot of LGBTQ plus. I can never remember if I get all the letters in there. But it was really great to see this huge diversity up on stage in attendance. So that was great after, a lot of challenges, I think, getting a more diverse speaker array. That was great to see. So I thought the SREcon organizers did a great job balancing the presenter agenda.
I agree. I think it's super, super important to get diversity of thought, have different ways of looking at things, different ways of, because if everyone's the same, everyone's thinking the same way, we're never going to move forward. And so, I think that's ideal.
Yeah, it was great to see. And then one presentation was about OpenTelemetry. And I'm a big OpenTelemetry skeptic, right? It's, I always hear that, OpenTelemetry will do this, will do that. It's the technology of the future. It feels like it always will be, right? I mean, it's taking so long to get standards finalized. I think we've only got metrics out of OTel right now, or is it traces? I can't remember. But logging is still, 6 to 12 months away. And I hear in 6 to 12 months ago, it was 6 to 12 months away. So it feels like it's really taking its time, right? The joke should be OpenTelemetry. What's the rush? But there were quite a few conversations from Equinix Metal about how they're using OpenTelemetry. And what was interesting was not the tech itself, but how they were treating it as it's not technology, it's like a socio-technical rollout. So it's not just something like one group can deploy and hope for the best, but they've really got to build bridges. They've got, they need to establish early successes with OTel and then talk about them really widely within the company so they can get other people, other developer teams, other SRE groups on board with using it and then sharing those results. So it's not just something like you can sprinkle in, like you have to have a dedicated effort to really roll it out. And I thought that was a pragmatic way to look at, what could be something interesting if it's finalized at some point.
Yeah, I agree. I think with OTel, it's a great idea, but there's just too many people involved, and the ability to deliver something quickly is just not there. I mean, I do like it though. It has a large number of people thinking about common standards, and I think that at least you're thinking the right way, thinking common standards is a way to get some results.
Yeah, and is it going to be useless? No, I'm not going to go that far. Will it live up to its promise? I think it's uncommon unlikely that it will. Particularly you have a lot of vendors involved, and vendors really want to preserve the status quo. We're a vendor as well, but I think we have a different story to tell here. And so I'm hesitant to kind of buy into the hype for OTel. A lot of analyst firms are really into it. They're like, oh, this is how it's going to be. And I feel like they should know better at this point.
Yeah.
Like standards are always challenging, especially when you develop them in the open with a lot of competing interests all trying to contribute.
Yeah, we've seen this before. I mean, I think everyone knows about the story of SNMP and what happened there, and that this is just something that you have too many vendors involved, you have too many competing interests, and getting people to sit with the best solution, and even though it may take away a little bit of my margin, getting to that is going to be tough. It's not easy.
Yeah, and we've seen it also with SQL, right? SQL is an international standard, but everybody customizes it for their own needs. And that drives lock-in. I think you're going to see proprietary extensions in OpenTelemetry, And that's going to drive lock in and protect revenues for sets and subsets of vendors. And I think that's just, unfortunately, that's the way just the world works.
Yes. I mean, things like transact SQL and all the different variations of SQL. That's part of it. I think you're exactly right. But I mean, we can hope for the best, but also have to prepare. And I think that's why having products like LogStream, having that flexibility of choice, being able to move, you have to keep your options open as a customer and as a data platform owner. You have to be able to adjust. Because
we've written a lot about that, like developing an options-based observability strategy, and like how, what the pillars are for that. And we can link that white paper in the show notes. But no, I think you're right. It's going to be interesting to see what happens over the next few years. Truthfully, it was just great to be at an event, right? Where you can talk to people and eat bad conference food. Everybody got tested every morning, which was great. Everybody was masked. And it was just good to be back in person at an event, even, if it wasn't like my core skill set, it was just good to kind of share ideas and see what people are thinking. So I'm hoping there's more of these in the future. Certainly there's going to be quite a few this summer. We're going to be in attendance at Snowflake Summit, at .conf for Splunk, maybe Cisco live as well.
RSA.
And RSA, right? Good call. Yep. Forgot about RSA. And Gartner Security and Risk Summit. We're going to be there as well. So I'll be at Security and Risk. Ed will be at RSA. And then we'll all be in Vegas. Oh, and we're also doing CribbleCon.
Yep, and Black Hat.
And Black Hat, yeah. Vegas in August. I'm going to let you go to that one.
Yeah. I think I'm gonna get an Airbnb in Vegas for June because there's just no reason to fly home.
No, there's not. Exactly. So those are my kind of notes from SREcon. Really good event. Hopefully there's many more in the future. So with that, let's pivot over to you and persistent queuing. This is something that's been in the works for a while, and we should talk about it.
So let's just go back to our deployment architectures we've had before. I've said this before. I'll say it 1,000 times. You always have to plan for failure. Things are going to fail. And so you have to look at your business objectives. Can you afford to lose data? Typically you can't, but then you have to ask yourself, what's going to be the cost of your data protection? So LogStream offers some very simple, very robust mechanisms for help protecting yourself against data loss. So one of the big ones is called persistent queuing. Right now in this release, persistent queuing is available on the destination side. So for example, I have LogStream. I'm sending data to Splunk. Splunk is down for some reason. My data going to Splunk is going to start hitting the file system. And so it's great. You have to plan for this. It's very important to start thinking about how long do you want to be able to persist data on disk? And that's all about disk space. It's just, that's all there is. And so you have to think, okay, are we going to sustain 1 hour, 2 hours, 3 hours? But so, and think of just like an SRE, start thinking about what are your business objectives and how long you're going to be able to sustain your service and not lose data. If you're logging 10 terabytes a day, that really adds up. And you have to be prepared to allocate that much disk space hour by hour in order to not lose data. One more thing to also think about: speed of data. Something I've managed, and I've learned my lessons the hard way, almost every way. If the disk is not fast enough, is not fast enough, you can also run into issues. It can take hours to then also restore your data. Imagine you're going into an outage, you have several terabytes of data on disk, and then if it's really slow, you have to be able to consume that data off the file system, put it back in LogStream, and push it out to Splunk along with your normal data flow, which is typically going to be quite elevated. And so you have to be prepared, if you are going to choose slow disk or persistent queue, of having to wait significantly longer than you want to in order to get that data back. Sometimes, it can be 10, 12. We had one instance, so it took almost 20 hours to restore from a queue because the file system was just that slow.
All right, hang on. I feel like you jumped ahead a little bit here.
Yep.
All right, so let's talk about what a persistent queue is.
Okay, so
let's take it from like the 101 level.
Okay,
and then we'll build up on it from there.
Okay, so a persistent queue is the ability, if your destination is down, So instead of sending data to Splunk or Elastic, LogStream will then divert that data to the file system.
To the local file system on the worker group.
To the local file, right? Exactly. Local file system of the worker group. You could also use NFS. Don't, but you could use NFS or shared file system. NFS is a bad idea because of the locking mechanism, but also because it's so slow. And when you are ready to restore your data back into your platform, it's going to take forever.
All right, so let's pause there for 1 second.
Okay.
So if you're not familiar with LogStream's architecture, there's a leader node, and that's the thing you interact with. That's where you do your configurations, where you set up your sources, destinations, your routes and pipelines. And then there's the things that actually do the work. Those are the worker groups. Those are separate from the leader. So the leaders can do the control plane. That is the control plane. And then the worker groups are what actually process the data. So if you do need to set up a persistent queue, it's the server where the worker group runs, not the leader.
Yeah, and that is true because the workers are what handles the data.
Yeah, and you can put, with our architecture, you can put the workers anywhere, right? They don't have to be next to the leader. They can be as close to where the data is originating as possible.
Absolutely. So, for example, when I was a customer, my leader was in Chicago, but I had workers in Hong Kong. Yeah, I had in Indonesia, Kenya, South Africa. I mean, quite literally all over the world. And so it was very pleasant being able to manage a global deployment from one place.
Yeah, and so the persistent queue, you said, is only for destinations. If the destination goes down, we will queue up that data. How do you configure a persistent queue in the interface?
Well, from the UI, when you go into destinations, there's an option called persistent queue, and so you have the ability to queue to the file system. You have the ability to drop data, or you have the ability to block. So let's go over those different options. The ability to send a blocking signal matters if you're using a log shipper, like say a Splunk Universal Forwarder or the Elastic One agent. That's going to take that block message and say, okay, I'm going to queue data on the edge. I'm going to queue data locally, and I'm not going to send it to LogStream until LogStream tells me it's okay. And so that's another queuing mechanism. You're queuing at the edge, but you have to be very careful because you could potentially run out of data at the edge much quicker.
You mean disk?
Quicker. Yes, sir. Yeah, sorry. Run out of disk space on the edge much quicker, and then you have another way of losing data. Also be aware for agentless communication style, say the Elastic HTTPS or Splunk HEC, you're sending data and there's no way to queue that type of data delivery. And so you're going to need to use LogStream. You're not going to be able to send a communication back to the Docker container to say stop sending data. So you just have to be careful if you're going to use that type of that blocking mechanism as a queuing mechanism. Another option is just dropping data. Data's coming in, the destination's down, LogStream's going to throw it away. That may be acceptable if it's data you don't particularly care about, but given how much money people are spending on these end-to-end setups, I'm doubting throwing that data away is going to work.
Could you consider a scenario where dropping the data makes sense if you're making, say, millisecond-based decisions, right? So like the half-life of that data might be 200 milliseconds. And
probably not, because there's probably going to be a retention or some sort of security requirement on that data. So say like you mentioned, like millisecond decision making, think about high-speed trading. So there is going to be, typically from a high-speed trading aspect, the SEC is going to have requirements on you to be able to reconstruct that trade if there's a question about that trade later. So you're more than likely going to have to be able to keep that data. So I can see if you're not in a regulated environment, and then it would be okay to throw that data away. But typically you're in a non-regulated environment, you're not going to see data that's that important over that short of a lifespan. It's possible, but you've got to look at your requirements. It's important to look at your security attention, compliance. There's a myriad of rules, especially if you're working in finance. I can see something like this in healthcare being important. And so it just depends on the business. And so I recommend talk to your records, talk to your data governance team in order to make sure it's okay to drop that kind of data.
Yeah, good point. It is case by case.
Yeah, it really is. It's so much of it depends on your industry. Because I mean, I've seen exactly what you're talking about, where the half-life of that data is literally milliseconds, and in high-speed trading, that's absolutely the case. But the issue is going to be when the SEC comes calling to investigate you, and you don't have the data to reconstruct what happened.
Got it. Got it. All right. So there's different strategies for persistent queuing. And then what else should we know about this?
Well, and so we talked about speed of the disk, because the speed of the disk only matters when you need to restore. And that's fine. If you're going to take a choice that I'm going to have the slowest possible IOPS in order to store my data, that's fine. But just be aware that's going to limit how fast you can replay that data back into your analytics platform. And again, that goes back to your business requirements. Do you have to have that data right away, pretty soon, or it is what it is and it recovers when it recovers? So just be aware of those things. You don't want to get caught short on a bridge in an instant when your VP wants to know when the data is going to be restored, because it's just too late then. So those are the kind of things you want to think about ahead of time.
Yeah. And so as you're filling the queue, if your destination is down, as you start to drain that queue, data is still piling up. You're still getting more data in. Are there risks that you might bury your destination?
Probably not, because typically so for example, if you're sending data to Splunk and Splunk's busy, it's going to tell LogStream to come back later. But again, that goes back to LogStream's going to queue. But if you have this much space set up, then your LogStream's going to queue, but it'll be okay. It'll balance out. The issue is going to be delay.
Okay. That makes sense.
So more often than not, I mean, you can do it. You just have to be aware that it's going to take time, and that's all there is. Now, you can create a fast enough platform, a big enough platform where you can inject data very, very quickly, but it's all about your cost and business requirements. And that's why it's so important to plan out these things early, understand your expectations of your business, understand the expectations of security, for example, and you have to have a very frank conversation that if you need this amount of data to restore this quickly, then they're going to have to fund it appropriately, because there is no fast and cheap. That just doesn't exist.
Yeah.
You can do different. Sorry, go ahead.
Well, one question. So, I get to play the noob when we do these live streams, right? I get to ask all the dumb questions and you can explain it to me. We support replay in LogStream. So you can take the data that's flowing through and you can dump it off to object storage, whether it's S3, MinIO, you name it. And then you can replay that later back through LogStream. And that's, we charge based on data in, so not data out. So it makes it easy makes the math easy. Right. Could you use that replay function as like a poor man's persistent queue?
Yes, you can, but typically that's going to be even slower, because you're going to have the distance of the restore. And also, and it depends on how you're subscribed to the object store and the kind of object store, but it could be pretty slow too.
Okay.
Typically, object store is going to be the best in a focused use case where, for example, ransomware, you have an issue with a particular host. So you want to say all the data coming to this IP or going from this IP, pull that from my object store and restore it. So that's going to be a subset of your data. We're talking about all the data.
Okay.
And so those are going to be, it's a matter of the physics of disk speed and distance. Or let's say IOPS and distance are going to factor into restoring. So yes, I mean replay could absolutely do what you're talking about, but you just got to be, you just have to factor those things in.
There's trade-offs.
There's trade-offs, and IT is all about compromises, and so you have to talk about my requirements versus what we're willing to pay for versus what we're going to get in the end.
All right. What else you got for us on persistent queuing?
I mean, it's something that, so I've failed miserably at and blown up more than once. And so this is something I always like to share, because hard-won experience of what works and what doesn't. And that's why I wanted to mention and emphasize, always think about your IOPS. If you're going to use NFS, think about your locking behaviors. And this is one thing I wanted to mention, is because we run into this too. Typically, when you're in the scenario when your Splunk is down and you're going to start having delivery issues and you have queuing, the thing you got to remember, now just remember this because we tried this one time with replay, was you're sending all the data to an object store, and then you have intermittent data going to your destination. And so what we ended up was massive duplication when we tried to use replay for this sort, because some data got through, some data didn't. And so this is just something to keep in mind, because it was impossible over like a 12-hour period to understand exactly what didn't get through. And so what we did is we ended up duplicating all the data that did get through. And so it created some problems.
Got it. Got it.
It's
That's good
hard. You
advice.
hardly ever have a hard down outage. It's just up and down, up and down. And also just, if you're a Splunk or Elastic administrator, you want as much hardware as humanly possible on your indexers in order to make problems like this simpler.
And this also applies for not just logging analytics platforms, but security platforms as well.
Oh yeah, yes, very much so. Talk about your SIM platforms, so even your cloud platforms, especially your cloud platforms like an Exabeam, which uses just site collectors, QRock, which is going to use your event processors. So you're going to have a small outpost essentially that has the ability that you send data to, it uploads it to your cloud-based SIM. This creates more complications because they typically can get easily overloaded. So you want to also make sure, and this is from a sizing perspective. This is one more thing I've learned the hard way. Always size your cloud collectors for uploading data to the peaks of your data. So if you're 20, 30,000 events per second, you want to size that to, what's the worst you've ever seen, or what's the worst you're willing to pay for. Because when things go badly, when you need something in a security event the most, you're typically going to have the most data. And when your platforms are undersized and you can't get data into your platforms, that's when your security people, your security VPs, your CISO get on the phone and get upset with you. And so you just want to be really careful with that. And also, if they say, no, we don't need to do that, and just make sure you get it in writing, take hostages and make sure you have it in writing to be able to point that out, because you're just, it's an awkward conversation, but at least you can have when you have your after incident review of, you don't necessarily want to say, I told you so, but you do want to talk, you do want to have a conversation about, we had this discussion. I told you what we
You want
needed
it
to do.
documented, right?
Yeah,
I mean,
you got to document it.
There's an element to CYA, I think, in everything you do in IT, right? You definitely
Right.
need to think about that, whether you're protecting your career or your team. Document everything. Ensure that you can recreate why decisions were made.
Right. And as part of a good design document, you want to talk about requirements versus your trade-offs versus the end result. And this is something for anyone who's early in their IT career, ideal almost never happens. Anyone who tells me the right way to do something is the only way to do something has never had to fund a project. And so there's it. Good.
No, I was going to, to your point about, about funding and, it's all trade-offs, and, we talk about economics a lot, of opportunity cost, and, you can do a lot of things, but what are you not doing? If you're not doing A and because you're doing B, what's the trade-off? Getting back to the persistent queuing though, like if a destination goes down and LogStream starts queuing data, does that integrate with our alerting and notifications mechanisms to notify the administrators that, oh, hey, this is happening right now?
Yeah, so that data is in the logging for LogStream. And so you have the ability to detect that and then open up a webhook into your favorite ticketing platform. So hopefully your favorite ticketing platform, you have internet access to get to open that up in order to have a notification. But yes, that is completely possible. Okay. Also, when you look at the status for your destinations, you'll very clearly see that they're red and that they're down.
Yeah, ideally you've got other monitoring involved as well, so that those so we're not the first thing telling you that something is down.
Right? God, I hope not.
You should get other notifications, but if not, we'll let you know, and you can connect to things. But you're right, you need to have internet connectivity, but in the hierarchy of needs, internet connectivity is number one, right? That's at the bottom. If you don't have that, you've got bigger problems.
I'll never forget we started to go to SaaS platforms, and we figured out the hard way that one data center didn't have redundant internet access. And so those SaaS platforms weren't worth a whole lot if you didn't have internet access.
A little harder to get to.
just a little bit. And
So
so
for
those are
persistent queuing,
yeah.
other than needing to, other than the cost of the infrastructure for the disk, appropriate speeds, etc. This is included with LogStream for free as part of the overall agreement, correct?
Yeah, it's part of the package. It's been there. It's been there
Okay.
since the very beginning. This is something that utilize a lot because it's all about that planning to fail. Because things are going to happen, things are going to go down. I mean, even if, for example, you're having to patch your Splunk indexers, so you have to take your indexers down. You have to have the ability to recover, the ability to not lose data. And that's why persistent queuing should be there by default for your everyday use cases.
Yeah, and it's important to know, well, why do we need that, right? And or is there some other mechanism in the worker group that would replace this functionality? Worker groups are inherently stateless, so we're not maintaining any kind of state between event to event and so on, other than metric summarization. Is that correct, Ed?
Yep. Oh, that totally reminds me. So for anyone who's using LogStream and Kubernetes, this stateless versus stateful mechanism is something very important to think about. Many people who run Kubernetes, Many people who run Kubernetes have rules about attaching storage to their containers in Kubernetes. And so LogStream works great in Kubernetes. It scales like crazy, but you may have issues with persistent queuing because you may have rules about not attaching storage to your Docker containers in Kubernetes. And so this is one thing to keep in mind. And as we mentioned before, that's a trade-off. Some people don't like it. For me, I this is something I wouldn't be particularly comfortable with Kubernetes. I think adding state to what's essentially more or less a stateless platform creates some complexity that you don't want to get into. But I think you have to very carefully think through what you're doing and think about the trade-offs.
Okay, you said a lot there. Summarize it.
Kubernetes is this is something we could have a whole conference over arguing
Right. So
about.
Kubernetes is
Yeah,
inherently stateless. So every time you turn it off and turn it
mhm,
back on again, it's day one for that container.
right,
And so you can attach persistent storage to a Kubernetes cluster or container. And
right,
then that's where you can use the you can kind of offload your state. And
right,
so if you deploy LogStream workers in a Kubernetes cluster, and you want to use persistent queuing, you would have to attach that persistent storage to your Kubernetes environment. And that
right.
may be something that your environment may not tolerate.
Or even support. I've seen some Kubernetes administrators who just won't permit it. And the idea is that you're just, it's like, it's an unnatural mating of animals that aren't designed to mate together. And so there's just some of the things that you just have to really think through because there's implications. You could have stability issues with your pods, complications. It adds complexity. How many things have to work in order for a process to complete? And if every new thing you add adds more complexity, the more likelihood that it's just going to break. So
Yeah.
that's
And
just
you may not have much control over what kind of storage you're using as well. It may not
right.
be optimal for the kind of performance characteristics that a persistent queue requires.
Yeah, I'll be a little more frank. More likely, it's going to be sucky storage. That's just not going to
Yeah.
work. Yeah,
Yeah. Not high throughput.
no, not at all. And so those are the kind of things you just have to think about. Because I think in certain use cases, like I've seen teams be flexible for certain things. They want Kubernetes, they want that instant scale, and they're willing to tolerate not having persistent queuing, not having a storage option, and then they have other worker groups that do. It's just depending on the use case, because
Got it.
there's no reason, and that's the beauty of LogStream is that if I want one worker group to be in Kubernetes and I want one worker group to be in EC2 instances or one worker group to be on-prem, not a problem. You can
All
manage
right.
them almost all the same. You have that flexibility to do what you want to do for your business.
Yeah. But you don't have to, right? You can mix and match the footprints for your worker groups.
Oh, that's what I'm saying is that
Yeah.
you can have worker group on each, and so you don't have limits. So, if, for example, if I have a syslog, for example, that I need an enormous amount of scale, great fit for Kubernetes, I'm just not going to support persistent queuing. But say for Splunk Universal Forwarders, I'm going to have a worker group that does support persistent queuing, and and LogStream makes that just trivial to do.
Got it. Got it. All right. Let's wrap it up.
Oh, I want to mention it's more or less possible. I'm not uncertain that we will have potentially maybe source persistent queuing in the near future, but we'll have to confirm that at a later date.
Okay. So if you want to know more about persistent queuing, either at the source or the destination, you can join our community. Go to cribl.io/community. You can hang out with about 3,200 like-minded people, all geeking out over observability data. And you can also play with our sandboxes if you want to experiment with LogStream, and that's at sandbox.cribl.io. And next week, we're going to be talking about our announcement that happens on Tuesday. So we'll be taking a deep dive into the new features that we are announcing on Tuesday. So Thursday at 2 p.m. Pacific, 2 p.m. Eastern, 11 a.m. Pacific. Make sure to join, and we'll step through everything that we're announcing on Tuesday. So if you have any questions, you can come and chat with us. We're also doing a webinar on Wednesday. So lots of opportunities to learn about what's going on here at Cribl with the evolution of LogStream and how we're continuing to kind of advance the frontier of what people are doing with observability data.
I can't wait till next Thursday. I think the live stream is going to be awesome. It's more or less possible. I'm going to do a demo of our new product. And so
no, you're doing a demo. You're doing a demo. I'm letting you know now. There will be a live demo, so we'll see how that goes.
Yeah,
very excited.
Yeah, I can't wait. I just the expansion, especially for administrators, I think it's going to be awesome. We're going to making things easier. That's why I tell people make things easier, remove friction from your life, and just I'm excited. I don't get excited about a whole lot of things, but this is something I'm pretty excited about.
Yeah, you only get excited about log analytics and brisket. I think those are the two things that really like.
Oh, you forgot about syslog.
Oh, syslog. That's right. That's the top three, right? The wife and kid. That's different. That's a different list. But yeah, for this
number 4. But yeah,
number 4. All right. Well, this has been a great conversation. Really educational. And then make sure to join us next week. We'll talk about our launch.
Awesome. Thank you, Nick. I appreciate it.
Thanks, man. Good talk.
All right. Take care.
Bye.